Mr. Wright here, and welcome to this run-through of this Edexcel Maths IGCSE paper from November 20. If you'd like to download a copy of the question paper, then you will find a link in the description. Hit the link, download the paper, and you can have a good go at the paper before watching the run-throughs. This run-through is in two parts, so there are two films. The first film for the first set of questions and the second film for the rest of the paper. And at the end of the second film, you'll find a short film of me letting you know what the grade boundaries were for this set of papers to enable you to work out what your grade would have been had you sat these papers. If you find this film useful, please do hit like, give me some positive feedback. If you've got any questions, do leave them in the comments, and of course I'll respond. And if you are preparing for your Edexcel IGCSE Maths exam, you might do well to subscribe to the channel. Right, good luck with the paper. Question 1. Right, if I simplify g to the power 6 multiplied by g to the power 4, I simply add the indices, and my answer is g to the power of 10. Simplifying this expression, when I divide, I subtract the indices, so that's going to be k to the power of 10 minus 3. So the answer is k to the power of 7. Right, now this one is something squared. So it's the something multiplied by itself. So that's going to be 3 times 3 is 9, c times c is c squared, and d to the 4 times d to the 4 is d to the power of 8. And lastly, for question 1, I need to solve this inequality. Let's subtract 7 from both sides, leaves me with 4x is greater than minus 5. And now I'm going to divide both sides by 4. You could do that on your calculator, of course. I'm going to write minus 5 over 4, which means that x is greater than minus 1 and a quarter, and you might have got minus 1.25 on your calculator. And that is question 1 done. Question 2. The table shows information about the lengths of time in minutes 120 customers spent in a supermarket. Here we are. So I know there are 120 altogether. And this table tells me, for example, that 6 people spent between 20 and 30 minutes in the supermarket. Write down the modal class. Well, which is the most common class? The most common class is the people who spent between 50 and 60 minutes in the supermarket, because there are 40 of those, which is more than in any other group. Work out an estimate for the mean length of time. So if I'm going to work out the estimate of the mean from a grouped frequency table like this, I'm going to mad it. I'm going to find the midpoints, then multiply, add, and divide. So my midpoints are 25, 35, 45, 55, and 65. So 25 times 6 is 150. 35 times 26 is 910. Lots of calculator action here. 45 times 31, 1,395. 55 times 40, 2,200. 65 times 17, 1,105. So I've multiplied. Now I'm going to add. Adds up to 5,760. And then I'm going to divide. 5,760 divided by the number of people, divided by 120, gives me a mean length of time of 48 minutes. And that is question 2 complete. Question 3. All right, I've got a parallelogram here, and I've got an isosceles triangle. I've got DE equaling DF, well, that's shown on the diagram. CDF and ADE are straight lines, and they're drawn on the diagram to be straight. An angle BCD is 58, that's labelled on the diagram. Work out the size of angle DEF. That's the size of this angle. So that's the angle I'm trying to find. Give a reason for each stage of your working. Okay. Right, well, the first angle I'm going to find is this angle here. And that angle, which is CDA, is 180 minus 58, because those angles in the parallelogram add to 180. So I'm going to say it's supplementary angles. They add to 180. Okay, so that means that CDA is 122. Okay. Now, I can find this angle as well then. That's angle EDF. EDF, and that also equals 122 because it is vertically opposite, isn't it? Vertically opposite CDA. Good. So that angle is 122. So now I can find what I'm asked to find, DEF, because that's 180 minus 122 divided by 2, because that's an isosceles triangle. So that will give me 180 minus 122 is 58, divided by 2, 29. And that is question 3 done, and I've given a reason for each stage of my working. Question 4. I've got 3 people here, and they're sharing money in the ratio 3 to 2 to 5. So let's just write that down. I've got A, I, and P, and they're sharing money in the ratio 3 to 2 to 5. The total amount of money that Isla and Paolo receive, the total that they receive, let's just have a look. Well, Isla and Paolo, Isla plus Paolo, they get, their ratio total is 7, isn't it? The total that they receive is 76 more than the amount that Andreas receives. Well, I and P, they get 7 between them, 7 shares, and Andreas gets 3. Okay, and what we're saying then is that the amount that Isla and Pedro receive, the 7 shares, is 76 more than the 3 shares. Well, they receive 4 more shares than Andreas, and so that 4 shares must equal 76. Okay, so now I can work out what 1 share is by dividing 76 by 4. So 1 share is 19, and now I can therefore work out how much money each person gets. Andreas is getting 3 times 19. By the way, I have no idea what the question is asking me at the moment. I'm simply working out how much money each person gets. Okay, and that's going to be 5 times 19 for Paolo, 95, right. So that's how much money each of them get, just in case that's useful. And the total amount of money that they receive, I'm probably being ridiculous now and working out lots of things I don't need to work out, but the total amount of money they receive is £190. Okay, now let's actually read the question. Andreas buys a video game for £48.50 with some of his money. Work out how much money Andreas has left after he's bought the video game. Well, we've already worked out that Andreas has £57, and so then he spends £48.50, which means that he must have 57 minus 48.50. He must have £8.50 left. And that is the answer to question 4. Number 5, question 5, percentages. So in this question here, we start with an annual salary of 3,130,000. We have to increase that by 4%. So I'm going to multiply it by 1.04, which gives me an answer of 3,255,200 yen. 5b. Right, we buy a car, and it's initially worth 750,000. Good. At the end of each year, it depreciates by 15%. That means that it is reduced by 15%. Work out the value of the car at the end of 3 years. Give your answer correct to the nearest Japanese yen. Right, well, each year it reduces by 15%, so our multiplier is 0.85 since we've got 85% of it left after a reduction of 15%. And we're reducing for 3 years, so the calculation of my calculator is 750,000 multiplied by 0.85 to the power of 3. And on my calculator, that gives me 460,593.75 Japanese yen. But I'm asked to give the answer to the nearest Japanese yen. So I'm going to write 460,594. And that is question 5 complete. Question 6. I need to find an equation for this line L. Well, I know I can do this using y equals mx plus c, where m is the gradient. So let's have a look at this line, see if we can work out the gradient. Well, what happens if I go from here? If I go 1 along, I go 3 up. So the gradient's 3, so it's y equals 3x. And then the c, of course, is the y-intercept, which in this case is minus 2. So my answer is y equals 3x minus 2. That's question 6 done. Question 7. The diagram shows a right-angled triangle, so I'm immediately thinking Pythagoras and trig. Calculate the value of x. I need to find the value of that angle, so I'm going to be using trig. Give your answer correct to 1 decimal place. I'm going to use trig. I'm going to use tan, because the two sides I know are cozy around the right angle. So that means that tan of the angle is the opposite over the adjacent. So on my calculator, I'm going to put 3.4 divided by 4.7, press the equals button, and then I'm going to shift tan, inverse tan that answer. That gives me 35.88 and so on. And so to 1 decimal place, my answer is 35.9 degrees. And that's question 7 complete. Question 8. The diagram shows an isosceles triangle. Okay, work out the area of the triangle. Right, well, it is isosceles. I'm going to find the area of this triangle. Then I'm going to need to know its height. Okay, so let's call its height x here. How am I going to find the height? Well, I notice that's a right-angled triangle now, so I can use Pythagoras. But if I do use Pythagoras, of course, that's a 4. So x squared is going to be 8.5 squared minus 4 squared. So x squared is 8.5 squared minus 4 squared is 56.25. So x, which is the height of my triangle, is the square root of that, which is 7.5. So the height of the triangle is 7.5. So how am I going to work out the area? Well, the area, of course, is base times height divided by 2. Now, the base of my whole triangle is 8, and the height is 7.5. So I'm going to do that on my calculator and divide my answer by 2. That gives me an answer of 30 square centimetres, and that is the area of the triangle. And by the way, that's 35 marks of the paper done now, so we're over a third of the way through. I wonder how many marks out of 35 you've got. That's the end of question 8. Question 9. The diagram shows a solid cylinder with a radius of 3. Okay, right. The volume of the cylinder is 72 pi square meters. Okay, calculate the total surface area of the cylinder, giving your answer to 3 significant figures. So let's just have a think about this. Now, there are a couple of formulas that might help you at the front of the paper. The first formula that will help you is the volume of a cylinder is pi r squared h. So the volume of our cylinder, so pi r squared h for our cylinder, is 72 times pi. Well, divide both sides by pi. Now I know that r squared h is 72, and I know r as well is 3, don't I? So that tells me that 3 squared, r squared, 3 squared, 9h is 72. Look at that. Divide both sides by 9. I now know the height of the cylinder is 8 centimetres. And the question now is, can I calculate the total surface area of the cylinder? Well, again, there's a formula that might help you at the front of the paper. It tells you that the curved surface area, the curved part of the surface area, is 2 pi r h. That's the curved surface area. And of course, if I'm going to work out the total surface area, I'll have to do the curved surface area plus the top, the area of the top, and the area of the bottom. So that's going to be pi times 3 squared for the top and pi times 3 squared for the bottom. So let's continue with this. So it's going to have to be 2 pi times the radius, which is 3, times the height, which is 8, plus 9 pi plus 9 pi. And I need to work out that answer to 3 significant figures. So some careful button pressing here. I've got 2 times 3 times 8, 48 pi, plus another 18. So I've got 66 pi altogether. Multiply that by pi, and that gives me to 3 significant, well, it gives me 207.34 and so on. And to 3 significant figures, that is 207 square meters for the total surface area of that cylinder. And that's question 9 finished. Question 10. The table shows information about the number of minutes each of 120 buses was late last Monday. So I see 10 were late. 10 were late. Well, more than 10 were late. But 10 buses were between 0 and 10 minutes late. And look at this, 6 buses, well, they were all between 50 minutes and 60 minutes late. Almost an hour late, those 6 buses. Well, some of them might have been an hour late, look, because the time is less than or equal to 60. So those 6 buses might have been exactly an hour late. Complete the cumulative frequency table below. So I've got 10 between 0 and 10. And now if I'm interested in here between 0 and 20, it's going to be those 10 plus the next 16. So that gives me 26. Then plus the next 44 gives me 70. Then plus the next 29, well, that takes me up to 99 buses. So 99 buses were 40 minutes late or less than 40 minutes late. Add on 15 onto that, gives me 114. And then the final 6 gives me 120 buses were between 0 and 60 minutes late. And that's part A of that question done. Okay, part B. On the grid, draw a cumulative frequency graph for your table. Right, I've copied the table down here so I can see it as I do my cumulative frequency graph. So I've got a cumulative frequency of 10, 10 minutes late or less. So I'm going to put across here. Okay, and then I've got 26 and less than 20 minutes late. Now, careful of your scale here. Is 1 square is 2 minutes here, so 26 is there. Up to 30, it's 70. There we go. Up to 40 is 99, so that's going to be half a square less than 100. Okay. And then up to 50, it's 114. Right, let's zoom in again, 114, so it's 110 here, so 114. And then up to 60, it's 120. So here is my cumulative frequency graph. Now you want to try and join it up with a smooth curve going through the point. So that's not bad for drawing it on a screen. Okay, use your graph to find an estimate of the interquartile range. Now, I'm just going to use a ruler for a moment. Right. So, finding the interquartile range. Well, there are 120 buses, aren't there? So, if I wanted to find the median, I would be looking at the 60th bus. I'd be looking here at the 60th bus. Okay, so the lower quartile is going to be the 30th bus. So I'll draw a straight line along here to hit my graph there. Much easier for you to do this on paper than it is to do it on the screen. So the lower quartile there, the 30th bus, how late is that? 22 minutes late. And the upper quartile, well, if the median's 60 and it goes up to 120, the upper quartile is going to be the 90th bus. That's there, halfway between 60 and 120. Okay, so if I were to draw a line here, and then a line down here, there we go, I make that one, the upper quartile, to be, well, I think it's probably 32. So my estimate for the interquartile range is 32 minus 22, 10. Use your graph to find an estimate for the number of buses that were more than 48 minutes late last Monday, right? More than 48 minutes late. So I'm going to find, I'll do this one in red, I'm going to find 48. I need to find out how many buses were more than 48 minutes late. Well, here's 48 minutes, right? I'll go right up there. So how many buses were less than 48 minutes late? Let's have a look. That looks to me like, remember, two squares for a two buses for a square here. It's 110. So that looks like 112 buses were less than 48 minutes late, and there are 120 buses in all. 120 minus 112 means that my estimate for the number of buses which are more than 48 minutes late is 8. And there's that cumulative frequency question finished.